So, as a supplement to the Chapter 3 lecture content, what we're going to be discussing today is the process of drawing Newman projections from a Dash-Wedge depiction of an organic molecule. So, let's start. I have my document camera pulled up and I have my model kit prepared and ready to go. So in this case, we're going to draw the Newman projections for a series of organic molecules, and we're going to take each organic molecule and we're going to show the different Newman projections that we can draw looking down either of the carbon-carbon bonds. And we're also going to look at how we can draw different Newman projections and different Dash-Wedge depictions of a molecule by rotating our carbon-carbon bonds and drawing what we see using the model kit. So first and foremost, suppose we have a structure with a general form that looks something like this. So in this case, we have a group a group F, and then we have structure components with Dash-Wedge stereochemistry. So in this case, we have groups B and C on carbon 1. B has a wedge, C has a dash. And we have groups D and E on carbon 2, where D has a wedge and E has a dash. So here's the Dash-Wedge depiction of the initial structure that we're going to be looking at. And what I would like you to do is I'd like you to take your model kit and prepare a model of this structure using the model kit. So here's the structure that I've prepared. So as we can see, we have atom A pointing down while being flat in the plane of the page. Atom B is wedged, it's pointing towards us. Atom C is pointing away from us. Atom F is pointing up in the plane of the page. Atom D is pointing wedged towards us. And atom E is pointing dashed away from us. Okay, so we have prepared a model for this Dash-Wedge structure. And this is a general model for this specific set of stereochemistries. So you may encounter molecules where you're going to have a range of groups, each with a dash or wedge. This template is general. So as long as you can identify which group is dashed and which group is wedged, we can draw the Newman projection quite easily. So first things first, we make our model. Now what we're going to do is we're going to look down a carbon-carbon bond. So in this case, we have two choices. We can look down a carbon that I'm going to arbitrarily label as carbon 1. As an alternative, we can look down. Let's use a different color for that. We can look down the alternative carbon that I'll label as carbon 2. So there are two possible Newman projections we can draw, looking at the molecule from the left and looking at the molecule from the right. So let's start with our first view, looking down carbon 1. So we're looking down the carbon 1, carbon 2 bond. So one of the easiest ways to think about what you're doing here is we're taking our whole molecule and we are rotating it 90 degrees. And we're rotating it 90 degrees to the left. To show what that looks like, here is our model kit. Here is the model of this Dash-Wedge structure. And to get the Newman projection, we want to look down carbon 1, which is right here. We're going to rotate our molecule 90 degrees. And now we're looking down the carbon 1, carbon 2 bond. Now, all we have to do is draw what we see. So in this case, in terms of our Newman projection, we see that the atom B in red is on the right, atom C in blue is on the left. So let's draw that initial depiction. A is pointing down, B is on the right, C is on the left. Let's now look at the back carbon. Atom F is pointing up in gray. Atom D is pointing to the right, down and to the right, and atom E is pointing down and to the left. So let's draw that. Okay, so with that, we have a full Newman projection looking down the carbon-1, carbon-2 bond, which we obtained by just drawing what we see from our model kit. Now, we can just as easily look down the other carbon, and the way that we do that is we just rotate our whole model kit 180 degrees. So here's our initial view looking down carbon 1. If we want to look down carbon 2, we just rotate the model kit so that we're looking down carbon 2. So let's draw that alternative view looking down carbon 2 towards carbon 1. So as we can see, this time carbon 2's in the front, F's pointing up, atom E is on the right, atom D is on the left. So let's just draw that initially. Let's now look at the back carbon atoms. Carbon 2's in the back, atom C in blue is on the right, pointing up and to the right. Atom B is on the left, pointing up and to the left. Atom A is pointing down. This is really why I encourage you to use your model kit, because it makes it very easy to draw out Newman projections. Now, if we wanted to convert this second Newman projection, these structures are related just because they're rotated 180 degrees. If we wanted to convert this second Newman projection into a Dash-Wedge depiction, we can do that. All we have to do is take this structure and rotate it 90 degrees. So in this case, we're rotating our structure 90 degrees, and that gives us a Dash-Wedge structure. So if we take this structure and rotate it 90 degrees, in this case, we are rotating it 90 degrees to the right. Let me just check that one more time. So here's my original structure. I'm rotating it 90 degrees to the left. Sorry about that. This lets us convert this Newman projection back to a Dash-Wedge structure. So in this case now, atom F is on the left, atom A is on the right. Essentially what we've done, and I'll show you this momentarily, is we've taken these structures, our initial Dash-Wedge structure, and we rotated 180 degrees. So let's draw what we see now. So we have atom F pointing up. We have atom E in green with a wedge pointing towards us. Atom D in purple has a dash pointing away from us. So let's draw that. Now, taking a look at the back, the second carbon atom, which is originally our carbon 1, the atom C in blue is pointing towards us with a wedge. Atom B in red is pointing away from us, so it gets a dash. Okay, now to prove the point that these two structures, these two Dash-Wedge structures that we drew are just the same structure rotated, let's prove that to ourselves. So here is our initial Dash-Wedge structure. And if I take this structure and I rotate it 180 degrees, that in turn gives me the second Dash-Wedge structure that I've drawn. Okay, really powerful stuff here. So as you can see, we can draw Newman projections for a molecule, and we can draw different Dash-Wedge depictions of the same molecule just by rotating it. Let's do another set of Newman projections. This time, let's take a look at what happens if we change the orientation of groups A and F. Again, we're still looking at the same molecule. We're just rotating and adjusting our carbon-carbon bonds. So to show us what's happening here, let's take a look at this Newman projection. And let's see what happens if we rotate our carbon-carbon bond. So in this case, what we're going to do is we're going to take this carbon-carbon bond and we are going to rotate the front atoms 180 degrees. So what does that mean? I'm going to be taking this carbon-carbon bond and I'm going to be rotating it a full 180 degrees. This gives me the following Newman projection. And I'm going to draw that Newman projection out. So in this case, as we can see, carbon 1's in front. Now this time, atom C is on the right, atom B is on the left, and atoms D, E, and F remain in the same position because we haven't rotated them at all. Okay, so let's just draw what we see using our model kit. Let me make the color correct. So atom A is up top. Atom C is on the right. Atom B is on the left. Atom F, D, and E don't change because we haven't rotated their bond. Okay, let's see what that structure's Dash-Wedge depiction looks like. And to that end, we're going to rotate our structure 90 degrees to the left. So let's convert this back to Dash-Wedge. That gives us the following depiction. So as we can see, this time atoms A and F are pointing up in the plane of the page. So it looks, our skeleton looks like this. We also see that atoms C and D are pointing towards us. They're wedged, while atoms B and E, the red and green atoms, are pointing away from us. They're dashed. So let's write that down. So atom C in blue is pointing towards us. Atom D in purple is pointing towards us. Atom B in red is pointing away from us. And atom E in green is pointing away from us. Now, we have drawn the Newman projection view looking down carbon 1, carbon 2. This is carbon 1. We can just as easily look at the alternative Newman projection view. So here we drew this initial Newman projection view looking down carbon 1, which is in front. We can just as easily look down carbon 2 by taking our whole model kit and rotating it 180 degrees to look down carbon 2. So if we take our entire model kit and rotate it 180 degrees, we can now look down carbon 2. This time, carbon 2 is in front. We see carbon F is pointing up, and let's draw out the remaining substituents. So carbon F is pointing up. Carbon E is on the right. Carbon D is on the left. Carbon A, substituent A is in the back. Substituent B in red is on the right, and substituent C is on the left. Now, this Newman projection can also be converted into a Dash-Wedge structure. And again, these two Dash-Wedge structures are related via a 180-degree rotation. So let's rotate our Dash-Wedge structure 90 degrees, and let's see what alternative Dash-Wedge structure we get. So this time, carbon 2 is on the left, and we'll draw what we see now. So as we can see, our skeleton is a little bit different. Carbon F is now on the left. Now we'll draw what we see. In this case, atoms E in green and B in red are wedged, pointing towards us. And atom D in purple and atom C in blue are dashed, pointing away from us. So we're still looking at the same molecule. We're just looking at different views, different perspectives of the same molecule that we can get via bond rotation. So as you see, for each Dash-Wedge structure, you can draw multiple Newman projections, and you can rotate your carbon-carbon bonds and draw additional Dash-Wedge structures for the same molecule. Now, the goal of this exercise is to talk about all of the possible Dash-Wedge structures that you can encounter. So let's take a look and let's see what happens if this time we take our back carbon groups and we rotate them 180 degrees. So let's see what's happening in the model. So first, let's get our Newman projection with carbon 1 in front. Now what we're going to do is I'm going to take my back carbon substituents and rotate them 180 degrees. This gives us a pretty interesting Newman projection that we're going to draw out. So in this case, the front carbon substituents and groups A, B, and C do not change. We haven't rotated that carbon-carbon bond, so we keep everything the same. Looking at our back substituents, group E is now pointing up and to the right. That's the green group. And group F is pointing down. And group D is pointing up and to the left. So let's draw that. So we have group F, group E, group D. Let's just check that we did that properly. Yep, everything matches. The nice thing about having a model kit is you literally can just draw what you see after bond rotation. Now, let's convert this Newman projection into a Dash-Wedge depiction. All you have to do is rotate your Newman projection 90 degrees. I find it's a lot easier to handle rotation of a carbon-carbon bond from the Newman projection. So as we can see in the skeleton, carbon 1 is on the left, carbon 2 is on the right, atom A is pointing up and to the left, atom F is pointing down and to the right. So here's what our skeleton looks like. Let's now fill in the skeleton with our groups. So in this case, our wedged groups, the groups pointing towards us, are atoms C and E. The dashed groups pointing away from us are atoms B and D, the red and purple atoms. Okay, so as you can see, we've drawn another Dash-Wedge depiction of the same molecule. And in essence, what we've done is we've taken and rotated this carbon-carbon bond 180 degrees. Okay. Let's go back to the Newman projection now. So we can draw one Newman projection. looking down, we can draw one Newman projection. Looking down, carbon 1. We can just as easily take this Newman projection and look down carbon 2, which is in the back. So let's rotate and let's look down carbon 2. And let's see what we can see. So in this case, rotating our Newman projection 180 degrees, we're now looking down carbon 2. In this case, as we can see, the carbon-containing atom F is in front, atom F is pointing down, atom D is pointing up and to the right, atom E is pointing up and to the left. Let's look at our back atoms now. In this case, atom A is pointing up, atom B is pointing down and to the right, atom C is pointing down and to the left. Okay, just like before, we can take this Newman projection and convert it into another Dash-Wedge structure by rotating it 90 degrees. So if we rotate this Newman projection 90 degrees, we get another Dash-Wedge structure. In this case, as we can see, we've essentially flipped our original Dash-Wedge structure 180 degrees. So now we have a skeleton that looks like this. Can everyone see how atom F is pointing down, atom A is pointing up in the plane of the page? In terms of the wedge substituents, we have atom D in purple and atom B in red. In terms of the dash substituents, we have atom E in green and atom C in blue. Okay. Again, just to prove that the two Dash-Wedge structures are rotated 100 degrees, here's our Dash-Wedge structure that we obtained, and here is the original Dash-Wedge structure. So there are many ways to draw the same molecule, and as a result, it's really useful to have a model kit as it allows you to very easily rotate your model, get your Newman projection, and even rotate carbon-carbon bonds however you please to get the molecule in the exact orientation you want to look at. Now, there's one more depiction that we have to look at. So let's rotate our carbon-carbon bond in this original Newman projection once again. And this time we're going to rotate our front carbon-carbon bond 180 degrees. So that way atom A ends up pointing down. So let's take our Newman projection and let's rotate our front carbon 180 degrees. That gives a new Newman projection. Again, here's the rotation. Here's our starting point. We rotate our carbon-carbon bond 180 degrees, and this yields our ending point. Okay, so let's now draw what we see. So in this case, we have atom A pointing down on our front carbon, atom B is going up and to the right, atom C is going up and to the left. Atoms F, D, and E, you draw them exactly the same. Let's draw that a little bit nicer, because we didn't rotate the back carbon substituents. Now, we can just as easily take this Newman projection and again convert it to a Dash-Wedge depiction by rotating our model kit 90 degrees to the left. And as you can see, that yields a Dash-Wedge structure. Here's the original Newman projection. Here is the Dash-Wedge structure. Okay, so now as we can see, atoms A and F are both down in the plane of the page. We see atoms B and E, the green and red atoms, are pointing out of the plane of the page. You draw that with a wedge. Atoms C and D are pointing into the plane of the page, so they get a dash. Now, we can just as easily, we were now in this Newman projection looking down carbon 1 and 2. We can just as easily look down the other carbon by rotating the Newman projection 180 degrees. So here's our Newman projection, originally looking down carbon 1. If we want to look down carbon 2, we can just rotate and look down carbon 2 after rotating our model kit 180 degrees. What does this tell us? Well, in this case, we see this time carbon 2 is in front, atom F's pointing down, atom D is up and to the right, atom E is up and to the left. Additionally, atom C in the back is up and to the right, atom B is up and to the left, and atom A is down. If we want to convert this Newman projection to a Dash-Wedge depiction, we just take our model and we rotate it 90 degrees. That in turn gives us the following. As we can see, our Dash-Wedge structure has been flipped 180 degrees. Same molecule, different view. The purple and blue atoms, atoms D and C, are wedged. While the green and red atoms, atoms E and B, are dashed. Now, to prove that these two Dash-Wedge depictions are just rotated 180 degrees, here is our original Dash-Wedge depiction, which matches what we have on the left. And here is the rotated Dash-Wedge depiction, which is the atom on the right, which is the structure on the right. Okay, so now we have gone through and we have discussed how to draw Newman projections from a range of Dash-Wedge structures and how to rotate Newman projections and interconvert between a Newman projection and a Dash-Wedge depiction of a molecule. What we're going to do as practice is we're going to look at some practice examples. And we're going to look at how to draw Newman projections, looking down carbon 1 and carbon 2 for the following structures. So in the first case, we have the following structure. We have a bromine, a hydrogen, an alcohol, and a chlorine. And I'd like you to draw the Newman projection looking down carbon 1 and the Newman projection looking down carbon 2. You're going to want to make a model for this structure. So at this time, you may want to pause the video, work through this example, and then we'll discuss. So the first thing that I'm going to do is I'm going to make a model of this Dash-Wedge structure. So first things first, I need to get my ethyl group. So I have an ethyl group. Okay. I'm starting with the right carbon, so I've installed my ethyl group. Chlorine, I'm going to use a green atom And the alcohol, I'll use a red atom. So here's the alcohol, it's wedged. Here's the chlorine atom in the back, it's dashed. Here's the ethyl group, it's up in the plane of the page. Now my methyl group should be pointing down, and I need a bromine and a hydrogen. So I'm going to use an orange atom for bromine and a white atom for hydrogen. You should have all of these in your model kit. Okay, so here we go. Let's just check that I did everything properly. Towards us, the methyl group is pointing down, the hydrogen is dashed pointing away from us. The alcohol is wedged pointing towards us, the chlorine is dashed pointing away from us, and the ethyl group is in the plane of the page. So if I want to look down carbon 1, I just take carbon 1 and I put it in front. So that in turn gives me the following Newman projection view. So now all I have to do is just draw what I see. So in this case, on my front carbon, the methyl group is pointing down, the bromine is on the right, the hydrogen is pointing up and to the left, as we can see in our Newman projection view. Bromine up and to the right, hydrogen up and to the left. Looking at our back substituents now, we see that the alcohol is down and to the right, the chlorine is down and to the left, and the ethyl group is up. So let's just draw that. One trick to note is that wedge substituents will both end up on the same side. And if you're looking from carbon 1's perspective, the wedge substituents end up on the right, the dash substituents end up on the left. Now, let's draw the carbon 2 perspective. Let's draw the carbon 2 perspective of this molecule. So here's our original structure. This time, if we can go from the Newman projection and just rotate it 180 degrees, or you can just tilt your model so that you're looking down carbon 2. Now that we have this view where we're looking down carbon 2, we can draw what we see. So in this case, the ethyl group is pointing up. The chlorine is pointing down and to the right. The alcohol is pointing down and to the left. On our back carbon, the methyl group is pointing down. The hydrogen is pointing up and to the right. And the bromine in orange is pointing up and to the left. So that in turn gives us the two Newman projection views for this molecule. As a bonus, let's draw the rotated Dash-Wedge structure, which would look like this. In this case, the chlorine has a wedge. The alcohol has a dash. The hydrogen has a wedge. And the bromine has a dash. One thing that you notice is that if you rotate a molecule 180 degrees, all of the Dash-Wedge stereochemistry flips. Let's do another example of drawing Newman projections. So here's going to be our second example that we're going to look at. This time we have an iodine with a wedge, a bromine with a dash, an amine with a wedge, and a hydrogen with a dash. Okay, so take a few moments to make a model, and then we'll discuss this example momentarily. So the first thing that we're going to do is you're going to get out your model kit, and you're going to make a model of this structure. So I'm assembling a model of this structure right now. So let's talk a little bit about how we check to make sure that the model that we made is actually correct. So in this case, let's break out the camera. Okay, so first I have my skeleton with both of the methyl groups pointing down in the plane of the page. The iodine is purple, is wedged, it's pointing towards us. The bromine in orange is dashed, it's pointing away from us. The amine is wedged, so I have to set it so it points towards us. And the hydrogen is dashed, so it's pointing away from us. So we have our model. Now, we want to look at two major views, carbon 1 and carbon 2. If we're looking at it from the perspective of carbon 1, let's do our initial guess without using the model kit. The methyl group is pointing down. Iodine is wedged, so it ends up pointing up and to the right. Bromine is dashed, so it goes to the left. The other methyl group is pointing down. The amine is wedged, so it ends up on the right. The hydrogen is dashed, so it ends up on the left. Let's now check that. So looking down, carbon 1, we see the iodines on the right. The bromine ends up on the left. The amine ends up on the right. The hydrogen ends up on the left, and both of the methyl groups are pointing down. So everything looks good. Okay. Let's now take a look down carbon 2. If I'm looking down carbon 2, all I have to do is take my model and rotate it 180 degrees. Now carbon 2 is in front, and I just draw what I see. So we have the methyl group pointing down. The amine is on the left. The hydrogen is on the right. The bromine is on the right. And the iodine is on the left. As a bonus, let's draw the Dash-Wedge depiction. So let's rotate this structure 90 degrees, and that gives us the following Dash-Wedge depiction, where this time the hydrogen and bromine are wedged, while the amine and the iodine are dashed. So there are still two more possible Dash-Wedge depictions that you can encounter, since I want this to be a general example. Let's do one more example, and we'll have about two more in total to do. In this case, let's take a look now at the following structure. So let's try to draw the Newman projections looking down carbon 1 and carbon 2. So take a few moments, make a model of this structure, and then we'll discuss this example momentarily. So first things first, the first thing you have to do is you should probably make a model of this compound. So let's put together a model for this compound. Okay, let's switch to the camera and just check. So in this case, we have the methyl group and an ethyl group. So the methyl and ethyl group are both pointing up in the plane of the page. The hydrogen is wedged, the bromine is dashed. The iodine is wedged, so the iodine needs to be in front, while the hydrogen is dashed, so it's in the back. So now we've generated a model that matches this Dash-Wedge structure. Now let's do a Newman projection. So let's look down carbon 1. So in this case, my initial guess looking down carbon 1, the methyl group will be pointing up. The hydrogen, which is wedged, will be on the right. The bromine, which is dashed, will be on the left. The ethyl group in the back is pointing up. The iodine with a wedge will be on the right. The hydrogen with a dash will be on the left. Let's see how well we did. So if we rotate this, we see both the methyl and ethyl group are pointing up. On the right, we have the hydrogen in the front and the iodine atom in the back. On the left, we have the bromine atom in the front and the hydrogen atom in the back. So we are getting pretty good at drawing Newman projections. To draw the Newman projection looking down carbon 2, you just rotate your molecule and you draw what you see. So in this case, looking down carbon 2, the ethyl group's in the front. We see that the hydrogen and the bromine atom are on the right, while the iodine and the other hydrogen atom in the back are on the left. Converting this to a Dash-Wedge depiction, if we rotate this structure, we get the following Dash-Wedge depiction. This time, the ethyl group is on the left, the methyl group's on the right. The hydrogen and bromine are wedged, while the iodine and other hydrogen atom are dashed. So as you can see, we're getting a lot more proficient at drawing Newman projections and Dash-Wedge structures. Let's do one more practice example. So I'd like you to draw both Newman projections this time for the following molecule. So you're given the following Dash-Wedge structure. I want to see Newman projections looking down carbon 1 and carbon 2. So pause the video, work through this example. You may want to make a model, and then we'll discuss momentarily. So our first order of business is to make a model. So in terms of making a model, let's pull up the document camera. So in this case, we have one methyl group on the left pointing up. The methyl group on the right is pointing down. The hydrogen is wedged, so it's in the front. The oxygen is dashed, so it's in the back. The fluorine is wedged, so it's in the front. The hydrogen is dashed, so it's in the back. If we want to do a first pass in terms of drawing the Newman projection looking down carbon 1, we'd expect the methyl group to be pointing up. The hydrogen is wedged, so it's on the right. The oxygen is dashed, so it's on the left. The back methyl group is pointing down. The fluorine is wedged, so it's on the right. The hydrogen is dashed, so it's on the left. Let's check to see if that's correct. So here's carbon 1. Let's look down carbon 1. And we see that the methyl group is up in the front. The oxygen is on the left. The hydrogen is on the right. On the back, the fluorine's on the right. The back hydrogen's on the left. The back methyl group's pointing down. If we want to draw the Newman projection looking down our back carbon, all we have to do is rotate our structure 180 degrees and look down carbon 2. Let's now draw what we see. So in this case, the methyl group is pointing down on carbon 2. The hydrogen is on the right, and the fluorine is on the left. On the back, the methyl group's pointing up. The hydroxyl group, the OH group, is on the right, while the hydrogen atom in the back is on the left. As a bonus, let's draw the Dash-Wedge depiction. So all we have to do is take this Newman projection and rotate it 90 degrees and draw what we see. This in turn gives us the following depiction where our carbon skeleton has been flipped. The hydrogen is in the front, the fluorine's in the back, the alcohol is in the front, and the hydrogen is in the back. So with that, we've discussed all of the possible ways to draw Newman projections from Dash-Wedge structures, and we've discussed how to rotate carbon-carbon bonds in Newman projections to draw new Dash-Wedge structures. So this concludes this bonus supplementary lecture focusing on Chapter 3, Newman projections.